So welcome to the video lecture series on finite languages and automata theory. We will check ambiguity of a grammar. We will check ambiguity of the grammar. So E tends to E plus E. And E tends to E star E, and finally E tends to A. So we will check whether this grammar results in ambiguity. Let us assume that we will take a string called as A plus A star A. We will try to derive the string called as A plus A star A. Now we will take up the first string. First derivation, E tends to E plus E. Now I take up the rightmost E here. Rightmost E, I replace it by E plus E is replaced by E star E. That means I replace the E by the second production, E star E. So it becomes E plus E star E. Now I replace it from the left side. So E is becoming A. And next is E star E, and another one is A plus A star E, and finally I will get a string A plus A star A. So the string has been derived. So another way of doing the same thing is E tends to, instead of replacing the E by the first rule E plus E, I replace it by E star E. So E star E. Now I take up the leftmost E here, I replace it by E plus E. So it replaces by E plus E, E star E. Now again you can replace E by A. So A plus E star E, then A plus A star E, and finally A plus A star E. Now for the same string you have two set of derivations. Apparently, ostensibly, it results in ambiguous grammar. So when you want to draw a derivation tree or a parse tree, so we'll take up a leftmost derivation here. This is E plus E. We'll draw a parse tree for this. E tends to, so E is derived as E plus E. Is derived as E plus E. Now next is I want to replace, I am replacing the right side E. Right side E is replaced with E star E. So right side E is here. So E star E. Now you can replace E by A, this E by A, and this E by A. So it derives A plus A star A. Now you take up this second derivation. So E is replaced by E star E. So E star E, E star E. Now you take up this derivation, E star E. Now you take up the second first non-terminal on the left side. This E is replaced by E plus E. So E plus E plus E star E. Now we can replace A by A. Again this also you are getting the same string A plus A. So this also obviously, since for the same string you have two different derivation trees, then it is ambiguous. So it is ambiguous. We will take up the second grammar, check ambiguity. Check ambiguity of S tends to ASB, S tends to SS, and S tends to epsilon. We will check ambiguity for this grammar. So we try to derive the grammar called as AABB. Let us ensure whether the grammar results in ambiguity or not. Now you replace S tends to replace by first rule A, S, B. Since S can be replaced by rule number 1, so this is rule number 1. When you replace S again by rule number 1, you will get AA, S, PP. So again I replace by rule number 1. Now I want to derive only AA, BP. Already I have 2 A's and 2 B's, which is actually required. The required string has been derived from this grammar. So I have to somehow eliminate this S over here. So eventually I try to replace this S by epsilon. When you replace by this S by epsilon, you will get AA, BP. So I apply rule number 3 here. So it becomes like this. Since the string has been derived as AA, BP. And another form of derivation is S tends to, I replace S by the second rule here. It is replacing SS. Now I take the second S here. So this S is replaced by S, A, S, B. Once again I take this S and replace by rule number 1. So S, AA, S, BB. Now the required string is AA, BB has been derived. But there are 2 S over here. Somehow you have to get rid of that. So S, if you replace by epsilon by the rule number 3, then it obviously it gets eliminated. So when you replace the first S by epsilon, you will get AA, S, BP. When you replace S by second epsilon, when you replace second S by epsilon, it automatically have AA, BP. So I have rule number 3. So this also rule number 3, so on and so forth. Now we will try to construct a derivation tree for both derivations which you have derived so far. I will construct the first derivation tree S tends to for this grammar A, S, B. So A, S and B here. This S has been derived once again by A, S, B. So you just take A, S and B. Now this S has to be replaced by epsilon. So epsilon. So when I replace by epsilon, this derivation tree is constructed. Now you take up the second derivation. So S tends to S and S. I am not touching the first S. I am touching only the second S. Second S is derived as A, S, B. So A, S and B. Again the second S is derived as A, S, B. A, S and B. Now the first S is replaced by epsilon. The second S is replaced by epsilon. Now I get the same string called as AA, BP. Since there are 2 derivation trees for the same string, so it is ambiguous. So this grammar is ambiguous grammar. So thanks for watching the video. Have a good day.